Good morning, Mohan.
Morning, Sammy. Can you hear me?
Yes, I can hear you. Can you hear me? Well, good morning. Can you hear me, Mohan, or no? Good morning, Rob. Can you hear me, Mohan, or
Now I
Rob?
can. Now I can.
Okay, okay. Maybe there's.
Morning, Rob.
Hi, good morning.
So, Mohan, did your the go-to meeting link disappear, or
Sammy, so start at 7:10.
no? Starting at 7 o'clock. At least the meeting I sent out was for 7:78. So, did you see the Zoom as well as go to meeting, or only your Zoom in your calendar? Almost 7 minutes after. Do you want to get started? Mon, can you hear me still or? You still
Yeah, we
hear
can
me?
hear. Yeah. We can hear you for sure.
Okay.
Yeah.
Yeah, we are almost 7 minutes over.
Hmm.
I'm wondering we can just get started and
Can't hear you, Sammy.
you cannot hear me?
I can hear you. So.
Me either. I can't hear Rob either. So
Oh, okay.
Rob,
Then it's
Rob
on your
also
end.
talking.
Yeah, I think it's on your end.
Yeah, Rob, while you are waiting, we
Yeah.
will be moving this meeting to Friday at 8 a.m. Pacific time.
Oh, okay.
The reason is I think we were originally expecting some PRC to join. And given low attendance from PRC, and we want to make it a little West Coast friendly.
Yeah, that's usually okay for me. My Fridays are good. So.
Okay. Hi, Mon. Can you hear us? No?
yeah, I can hear you. Yeah.
Okay.
There we
Okay.
go. All right.
Okay. Good. Thank you.
Right.
Yeah, let's get started. A
Yeah.
couple of logistical items we will cover before we move to the meeting.
Yep.
Do we have any opens today?
I'm sorry. Any what?
Opens.
Oh.
No, Sammy. No.
Okay. If not, just I was talking to Rob when you were joining Mon. We will be moving to Friday 8 a.m. Going forward. Because I want to make it a little more West Coast friendly. 7 a.m. and Monday morning seems to be not a good time.
Yeah.
It starts your week off strongly, right?
Right. So we will be the morning. This is probably the last meeting. We will meet in the morning unless something else comes up.
Yeah. Much
Okay.
better, Sammy. Much better time slot for West
Are
Coast.
you both on the West Coast?
Yeah.
Yeah. Okay. Thank you. The other logistical item is we are already moved to Zoom meeting. We are meeting in Zoom, but looks like some of your calendars may not have updated to Zoom. I don't know. That is when the OCP sends out, unless you go and delete them, does not get deleted, I believe. I will continue to send the Zoom link also as part of the agenda. That way, at least people have not made a mark. At least they can mark in their local calendars. So the other update is the metrics, DCEM metrics. We want to kind of give a summary of the things to the OCP when we are meeting in the Global Summit. And we were meeting last 2 or 3 months, and we were kind of going over what are the different gaps and what we need to work on. So Mohan really hosted a lot of different meetings in this area. So we will let Mohan to summarize it, and we will in OCP presentation we will I'm going to present the most of the content, but I'm going to be borrowing a lot of content from over there.
No problem, Sam. Yeah, I have
Good
a
morning,
couple.
yeah.
When you're done, I have a couple of slides, but I think it's given it's the last day for present submissions. I want to show you guys these slides before it's too late. So
Yeah, go ahead. Yeah.
Yeah, let it come up. Okay, up, come on. Give me a second. Switch the slideshow. Okay. Good. You see it full screen, right?
Yeah, we can see it now. Yeah.
So if you're going to pick up the slide. Let me walk through this and I'll justify it in the next slide. I only have a couple of slides, so I don't have a whole lot. But I feel if you're going to do IUE, then we need to be comprehensive. Semi, this also completes your AR, right? Because you wanted to comprehend the workload. So I modified the definition to say IUE under given load is total active server power, which like if you see the wall plug there on the top, whatever the power is coming in, minus the computational power, but so divided by the computational power, where the computational power is defined as total server power minus the thermal power at the same load minus the power conversion losses at the same load minus the idle losses, right? So now you truly know what's going to actually power the silicon as opposed to what's being wasted at that platform level, right? So getting this to one would be next to impossible today, right? So last week I talked to you guys about solutions where you can kill the thermal power by shifting it away. You can kill the conversion losses, but there is nothing you can do to kill the idle losses, right? Idle losses are a natural part of how silicon is made today. You can minimize it, but you cannot obtain straight linearity. So I feel like this would be the best way to represent it, and also it comprehends whatever Meta was trying to do. It's too bad there's no one from Meta here. What Meta was trying to do very well in terms of what they wanted. But the part that I think they missed out on was underload, right? Because, and I'll show you in a second why that's important. A couple of graphs to walk you guys through. Any questions on this definition before I jump?
Quick one, like, so do we want to, this one IUE is going to be sigma of what is running, right? Or this is
No,
more of a theoretical calculation?
Just take a targeted platform, right? And then you say, for that you're calculating IUE because it's a lot closer to it lot closely models, like, if your PUE is approaching 1, then it doesn't say anything about what's going on. Whereas if you look at IUE, it tells you a lot about how much power are you wasting. See, because PUE is essentially always aimed at indicting the data center guys, right? Never the IT guys. IUE is more looking at, is a lens on the IT folks and say, how much are you actually wasting in the path to powering the silicon? How much of that power actually was useful power, right? I mean, I'm sure I'll get into a huge debate, or if I say total useful power, so I say total computational power.
So here total server power is thermal power.
Yeah, total server power is like what's coming in. Let's say
you mean to the
server
thing, right?
Take a 2-socket platform.
Right.
Power coming in through your PSU, that's your server power. AC power coming into your platform is your server power. Computational power is really, it's an abstract. There is no physical equivalent for it. It's actually what's the useful power that exists after I take away everything that was just going to waste, right? If you have fans, you can argue that like they're not really making any compute, right? If you have DC to DC losses, they're not contributing to anything except loss of power. Same with AC to DC losses and idle losses. Everything is taken away, then you have what's your useful, what useful power left there. Now that ratio is interesting because if all of these things that we are subtracting are zero, then IUE will be one. But that in that day is pretty far away.
So thermal power basically, like if it is fan or it's going to be liquid cooling, how much you are spending for that?
Exactly.
Okay.
And then even if you say, okay, I'm going to do a DC bus bar, okay, do a DC bus bar, but you have DC to DC losses on your motherboard. It's not zero.
And when I go to the ideal loss is you going to pre-compute and have some factors built into that.
I'll show you idle losses.
Okay.
So, okay, since you started there, look at the right-hand side of the graph. There are two graphs on the screen, but look at the one on the right-hand side. In an abstract fashion, so what is happening here is that you powered on your server, okay? You're not doing anything with it. There is no load on it. It's just sitting there.
Right.
It's not consuming zero power at that point. It's consuming some power. That power is active idle, right? And then you start applying load. So the x-axis is load, y-axis is power. And then the power starts creeping up. And eventually, at some load, it will hit the peak power and it will stay at peak power from that point on. Typically around 70% load, and then it will stay for spec power benchmark. So my point is that you're never going to get away from the fact that you have this active idle component that is always going to be always going to be a part of your power, right?
Yeah, I think that's true. I think my question is more like you have to compute ahead of, while running, you cannot compute idle power, right? So
you just need to know what idle is from somebody. Yeah,
right.
Yeah. You're right. I see. If you're asking, how do I compute it? Well, somebody has to give you, just like fan power. How do you compute? You have to. Somebody has to tell you what the idle power for something. If you plot this graph, right, then you know exactly what the idle power of that system is, and that idle power has to be, taken away. And also, right. So notice that the idle power doesn't change with load. It's a constant. It's a tax that you pay because of the way things are made in general, right?
Correct.
Okay, so now back to the slide on the left. So essentially, again, showing the same thing, right? The light blue bar is the idle power. This is an actual platform. I just normalized them, so names have been changed to protect the innocent. Here, right? So the light blue bar is the idle power, and it's, as you can see, it's staying constant around 16-17% of the total. But thermal and power losses are increasing with load. This is why I'm saying we have to compute at load, because otherwise you really are not getting a good picture. Had you just measured at idle, you would get a picture that's not really that interesting, right? So if you say, hey, I'm always going to ask the customer to report IUE at 50% load, you get a more interesting picture of what's happening. Better yet, if you ask them to do multiple load locations, you get an even more interesting picture. Idle tells you very little, because at idle, look at the losses, they're very small. But the losses increase, I don't know linearly, but they increase with the increasing load. This is what, Sammy, you were asking what happened. So I modeled it for you.
Thank you. Yeah. So here, in the ideal case, there is idle power, as well as there is some heat and
Right, some power losses.
Right. So do we subtract from the total when we
Yeah.
report there? Or?
All 3 bars have to be subtracted because these are wasted power. They didn't
Right,
do
right.
any useful work.
Right.
The left-hand chart is showing things that didn't do anything useful for your server.
Right.
Right. So, I mean, ideally, like, if we could be silicon gods for a day, right? The active IDO on the right hand side, the line would intercept at 0, 0, 0.
Right. Right.
Then whenever you idle the platform, the power will drop to 0, right? But that doesn't happen today in anything in the world.
Correct. Yeah, I think there's a power component that is getting consumed.
Mm-hmm.
And also, like when we are modeling the thermal losses or power losses, do we subtract that? I think if we go back to that formula, right?
Yeah, you're subtracting the thermal and the power losses there.
Yeah.
No,
Question on.
Good.
Oh, I'm sorry. Question on the other graph. When you had the bar graph, the thermal, was that? Can you go back to that slide?
Yeah. Yeah.
Yeah. So the thermal losses, which are on the left, are those fan power?
Yeah, fan
losses?
power. Yeah.
Okay.
So I took a 2-socket platform and basically took the fan losses, and then I clubbed the AC losses and DC losses together, and then of course I put the idle losses. Yeah.
Okay. Good. All right. Thank you.
Yeah. Like I said, names have been changed to protect the innocent here.
Yeah.
Yeah, it's just fan losses. I didn't want to say fan losses because, like somebody will say, oh, well, it's some other platform that's not fans. It's more than fans. So it's okay.
Yeah. No, I get it. I just, I just want to make sure thermal wasn't like electricity to heat loss. It was actually
No.
the energy
No.
to the fans. Yeah.
To the fans. Yeah, exactly.
Yeah. Good.
Yeah.
So, Mohan, if you go back to the previous one.
Yeah.
So in this one, we are subtracting ideal losses. Ideal losses in terms of power, or ideal losses in terms of thermal and conversion.
They're all power numbers. I mean, they're all watts. You're subtracting them in watts.
Okay. So in the ideal, when we say there's 3 component of ideal there. Okay, got it. Okay.
Yeah.
So it's ideal. Yeah, ideal. I think it's basically what we are saying is ideal power that basically includes the total power consumed when it's idle minus the thermal power when it's idle minus idle power conversion losses at idle. In the ideal losses there you can say 0, right? Okay.
That's right. So this is why I said that we need to define this whole thing under load, because trying to define it under idle will get you nowhere, right? Because you'll get to 0. Right. So let's not define IU at idle. Let's define IU at some load higher than idle, because idle is a component of it. So if you try to measure at idle, you'll have a divide by 0 problem.
So now I think I got the idle correct. Now we want to, let's say, we want to take the hypothetical example, right? Now I want to model for a peak. Again, it's computed, or really are we really loading the system?
No, this is actually full load on the system, Sami. Like on the right hand side, literally it's saturated to the TDP at that point.
That what I basically mean by that, Mohan, is we are going to load it at a peak and measure it, but no measurements are really needed during runtime, meaning while operational. That's what I'm trying to say. Like while operational, nothing is going to be in peak, nothing is going to be mostly in idle. You were somewhere in between that. It may not be 50%, maybe 30-40%. Some system may be higher percentage. I'm trying to see how do we put them together, right?
Oh, let me see if I understand what you're asking. You're saying, hey, what if So your question is, what if how do you measure this as runtime? Is that what your question is?
Correct. Yeah. What percentage loads? We cannot say percentage of load because in a rack you may not have a 50% distributed across all the nodes, right? Some may be at 30, some may be at 70.
Oh yeah,
right?
yeah. So, how do you know what the loading factor is? Common. So what I'm saying is that either you provide a load, right, and like a target load, and say, measure. Tell me what the measurement is at this load on average. So this goes back to a picture I'd shown you a long time ago. Let me see if I still have it. So where is it? I don't know if I have it here. I'm looking. It may not be here. One second to look again. No, I don't have it here. I'll put it in if you want. So you have to pick the target load. So today, so if you want to take PUE, for example, leave IU for a second, right? If you want to take PUE, people will come in and say, hey, can you just go? It's time to measure up PUE. You can just say there are multiple ways to measure PUE, right? If you're you can do it continuous, you can do it weekly, you can do it monthly, right? And then you do the average of them, running average of them. So let's say you're one of those guys who does it monthly. So on that day, when you're going to compute PUE, you, the IT person or the data center person, gets to decide what load is on your system. So if I were the IT administrator, I would put the maximum load on the system so my PUE looks good, right? Because you're increasing the numerator. So
is it
sorry,
monthly,
the
weekly sum, or is it a point of time?
No. So point of time is one way, but really data centers are supposed to do PUE on an average. So that average is weekly, daily, weekly, or monthly.
So it's totally consumed for the week or month daily, right?
No. You measure it every week and then take the 52-week average, for example, or you measure it every month and take the 12-month average.
And in a point of time, or is it the total month, how much power is consumed?
No, it's a point of time.
Okay.
Right.
So that means this is not really a representative of what is really
exactly. So continuous is 15-minute intervals,
right.
And then you load all of them. That's the more representative. That's what you're looking for.
Right.
But you understand that just to do that takes a lot of sophistication, right? You need to store all that data somewhere, right? You need to make sure you don't perturb your data center as you're measuring this. Lots of automation needs to go. Maybe only the big guys are capable of that, right? You can't expect some guy with five racks to be doing the continuous measurement, right? So anyway, right. so multiple ways are allowed. My point is that if you say monthly, I get to pick the day when I'm putting the load, and I put whatever load I want, and that's what you get to see. You don't get to see the picture that you may want to get, which is what's the realistic load, which comes in continuous, right? Continuous gives it gives you the much better picture. That doesn't happen, right? Because there is, even though, by the way, the spec writers for PUE, they did a very good job. It's just that in application, we don't really follow those guidelines very tightly because PUE is not defined under load, right? So what I'm saying is that if you're going to define a new one, we should define under load, and then where Sami you're leading to is something I didn't come prepared for, but next time we can do it is we can talk about what would be the recommendation. How do you make sure that you specify that you want to do this? So if you can have only one number, what number do you pick? I would say you pick the number that's the average for data centers in general. So data centers IT loading, they try to keep the load around 60%, right? 40 to 60%. So let's take 60% and say, you know what, we need you to measure IUV at 60% load whenever you measure.
Yeah, what I'm trying to see, Mohan, is how do we operationalize at the end? Like people can, without like, if you say like you have to load a special workload, maybe while onboarding, basically meaning like then when they commission a new servers, they can measure it.
Mhm.
Then after that, it goes to production, right? They're running production workloads. They may not be willing to change the workload for just for measuring this again and again, right?
Yep. So then you're not getting a good picture. So, but
Correct.
at least you should know.
Right.
But minimum, what I'm asking is that tell me what that load is, so I know where I am on this curve on the right hand side. So or
Right.
in the left hand side, whichever one, right? Because your powers and numbers are not the same. At least there is truth in advertising. You see what I mean? Instead
Right,
of
right.
just
So
saying, oh, I have great numbers.
if I take a rack and if I want to say call out some load, so if it is all homogeneous systems, you could potentially say like each system just determine the load number, like I don't know, some may be 40, some may be 60, and some may be 50. If you average them, basically like what we are saying is average of those things, right?
Yeah.
As long as if it is a homogeneous system.
Right.
If it's heterogeneous, then it becomes a little muggy, right? Because
Little more. You're essentially looking at the average of a bunch of systems load, which gets to be a little bit more tricky. But it's the same as it's same as what we have today, right? We're asking for a given system, what is your load? So uh, it's not that bad. But I see what you're saying. How do I tell you on in a fully functional production system that you need to have load X? I'm saying, yeah, maybe you don't. Then you say, tell me what load you measured under, because the problem is today people say, oh, my system is better than the other system because I'm at PUE X and PUE X is less than the other one. Is it? Because we don't know anything about how you measured it. And I'm saying we need to, if you're going to design a new metric from the get-go, you need to make sure that that's not possible. So yeah, I don't care that your load is always 30%, for example.
right.
As long as you don't come in and say you're better than some guy who's operating at a load of 70%.
Yeah, so that's why
Based
I'm
on
kind
just the
of
numbers.
right. But I'm wondering more like, do we want to say like they can report whatever the load, but as long as the load with the percentage, right?
Yeah, exactly.
And that we need to define how do they average them to get that number, right? Because you could say, I could have a smaller system, maybe fully utilized. And if you have a bigger system, is not fully utilized, then when you average them, if you treat every system as a system, you're dividing by number of systems, then it is not really like apple to apple comparison, right? Or if you say like each system supposed to be same TDP, then you're really saying all of them are equal as long as it's consuming same power, right? Max power. So we need to figure out some way to how do we average them, right? Or recommended averaging mechanism.
Yeah, exactly. And we can start with saying, just tell us what the load is, and then at this load, this is the IUE, and then so one thing I didn't plot is what will happen to IUE. So the IUE, as you can see, at peak will be better than it will be at 50% load. Agreed? Right? Because you're
Right.
subtracting more things out of this whole
Right.
thing, right? So if you essentially take that kind of an approach, then you can say, give me your numbers, and then we'll figure out. You don't have to artificially put loads on the system, which is what your concern is, Sammy, right?
Right.
Yeah.
Because
I'm
at the end we need to figure out a way this gets utilized and measured, right? Otherwise, the active and the peak is probably computed at when the system is onboarded, right? once you do the measurement, are you going back and measuring again, right?
I mean, like, are you redoing your calculations again to see if everything is okay?
Right, right.
You might, but you don't. I mean, I don't know if we are requiring it. They may do that for other reasons, I would say.
Yeah. They may do it in a data center side, but if we say they have to do every month, then they will complain. You are putting a tax on me that I have to kit the customer or clear and put this one back, right?
I agree. So we're not requiring them, hey, go back and do this every whatever period.
Right.
Right. So
right.
that's fine. I am good with that kind of. We don't have a requirement that says you have to. I mean, this way we need to have what PUE does. We need to have a discussion on how PUE does it, right? We wouldn't. We'll give all the flexibility, but we'll also make sure that it gets reported on the actual load. I mean, your load is your load. We're not going to say you must have this load, right? But please don't measure it at idle and tell us this is what it is, right? Because it tells us nothing about your system.
Yeah, then the other question comes into play, Mohan, is when you report that particular percentage, then are they disclosing what they're running at? They're basically think
it's a very good question, Sammy. They say no, but so let's take
some ABC data center, right?
Yeah. So let's say it's a social media type thing. So the fact that they run at a certain load, you're saying the fact that they say this is my load gives something away on the way they workload. I think that's a stretch, right? Because once again, next time we talk, I can talk to that also. You remember the actual data center utilization numbers are also about availability zones and all that stuff, right? It's not just about because like when people say, I mean, when lay people hear data centers are 60% utilization, they go, wow, what a waste. But it's not a waste. It's designed to be operating at 60%. You don't want your data center operating at 100% utilization. Because when there is a failure, you have no place to go if you're operating at 100%. Correct? So my point is that if that's the case, then why would they worry that something is being revealed? Because a lot of this other stuff exists inside. So you can't tell whether this is a workload doing it or whether this is their policy on how much they're going to keep idle that's doing it. So there's a lot that could be the reason. So why would you just assume that it's because the workload is a certain way?
Yeah, I think that's the main thing, right? You can say my current IUE is this one, but without percentage, if it comes out, then you're not comparing it the same. Are we really effective or not, right? But at the same time, are they willing to say the percentage, right? Are they? Yeah, that's.
Yeah, is anyone willing to say what the percentage is? That's always a good question, Sammy.
Right.
I mean, again, go ahead.
Or they may say like they might have taken in multiple different points and they can decide which one they want to disclose, right?
Maybe whichever one they feel is the one that's, yeah. I'm just saying if we are at a point where PUE doesn't work and we come up with something like this, we could, but and this is the way that it will work. But now the question is, now where do we go from here on getting them to give you a true picture that's representative?
Right. Yeah, the formula looks good. I think it basically conveys all the important item related to the power that really what's going in the computational side, right?
Exactly. Exactly, because we kind of, if you're going to take that thing, we can't just say, oh, power losses and thermal losses. Well, silicon losses are as much as part of it as power and thermal losses are.
Good.
All right. So the only other thing I had for today was I had presented the partial PUE, and then I was looking at the spec and I was trying to recalculate the equation. So the equation I had in my previous deck, I don't think it's quite right. You can't just summate them all. The summation would look like what I'm showing here. So essentially, it's not just I add up partial PUEs and come to the full PUE. You take the non-IT energy in every zone and divide it by the IT energy in every zone and add up all of those things together, and then you get your full PUE if you're just calculating a bunch of partial PUEs. So this, unfortunately, they don't have this equation either in the PUEs in the spec. I mean, this is not related to everything else I presented today. I just wanted to be complete because I was doing the math and I realized that it doesn't, simple summation doesn't work. So it has to be like this.
So let's say you have multiple zones. So you
Yeah.
cannot add them and divide by same numbers, right?
Because the zones, no, it's not because the zone dependent. It could be side by side or linear like this that are completely independent and so on. So essentially, you have to take the non-IT and IT load and summate all of them, and then you have a good chance of measuring them. I don't know if just taking partial PUE and adding them up will get you to where you need to be. Right? Like if you're just doing a straightforward average.
Okay.
You see what I mean?
Right.
You can do a straightforward average of these things because I don't know if they're equally contributing in some sense.
And you don't really divide by number of zones, right? You just divide by how much energy is consumed.
Like for here,
on each,
in the, this example on the left-hand side, there are 3 zones. In zone 0, there is not even IT. It's just power and cooling.
Correct.
So then it will be this power and cooling contribution, this power and cooling contribution, this power and cooling contribution, divided by these 2 IT load contributions. That's your PUE.
Right. Okay.
Right. So that's all I'm trying to say. So
so zoning really does not matter actually.
No. So we'll have a longer conversation on this because the zoning, it allows you to have focus, but zoning also gives you a false view of the data center.
Right.
Because you look at all this. I mean, I'll take these liquid cooling PUEs that are like minus 0.07 and so on. All they're saying is that, hey, if you confine yourself to one rack, I can give you 1.07 or whatever the number, 1.1, pick a number, right? But it says nothing about what the actual PUE is going to look like.
Yeah, in this example also, right? For example, zone 1 might look better, zone 2 also might look better, but overall, because zone 0 is really like not doing anything but consuming power and cooling, right?
No. So it's more. So let's take. Okay, I don't mean to pick on somebody, but let's take abstractly direct chip cooling. So the direct chip cooling guy will say, here is my zone N, here is how much power is going in, here is how much cooling is going in, and here's my PUE calculated.
Right.
But that power and that cooling is not sufficient to cool the IT load, you see.
Correct.
Because
it still needs, zone 0.
Yeah, because you still have some zone 0 contribution to cooling that's needed because, direct chip only cools that one chip. Rest of the motherboard is cooled by regular air, which is coming from zone 0. So they don't look at the zone 0 contribution. They just say, my part, I'm doing great. I'm almost 1.
Right.
So which is fair, right? They're saying, I've designed a solution that is not impacting power, right? I'm very minimal on power. But does that mean your total PUE is 1? No, because you have your server fans are still running at like I showed you guys last time, still running at 50% load or whatever the number is. So you have zone 0 contributing heavily to your IT load. But when you just look at the zone N, you get a very skewed picture of what's happening.
Right.
That's my point.
Yeah.
But anyway, that'll take longer time. I thought I should fix the equation before it's too late, in case you wanted to use it.
Yeah.
That's
I would like to. Yeah, this is a good way of representing. First, as a OCP, we are driving as a system level and a rack level, right?
Exactly. And say, this is our focus and this is what it looks like and whatever, and we'll go through that.
Okay. Yeah, this is good. That's good.
All right.
Anything else, Mohan?
That's all I had, Sammy, for today.
Okay. Yeah, I think send me the slides, Mohan. I will integrate as part of the things today. Yeah. So next week, that is probably target for the white paper. We can spend some time and get that draft written more.
Sure.
Yeah. So that we can start reviewing that content before. I think we have only like
2 weeks.
Less than 2 weeks, right? Yeah.
Yeah, that's okay. I mean, today is the day. You guys know what the deadline is? Today at 5 or today end of day, meaning by midnight?
They didn't say it. I think it's today end of the day.
Okay.
Oh, for the presentation?
Yeah.
Right.
Yeah. Oh, I thought it was already over, but whatever. I mean, to be honest, you can always tweak it at the end. I have found.
No, that's okay. They want to see most of the content in. Like if we have some tweaking, that's we can probably do it anyway. They will also give us some feedback because there's some final review is going to happen. What they want to do is they want to get everything ready, loaded in their systems. So it's the whole flow and all the basic logistics are set up, right? Yeah, I will complete the presentation and I will submit it before. I think I'm targeting by 3 I want to get it all done.
Okay. Because when Kate gave the extension, I didn't see whether it said what end of day was. But usually it's like midnight. So I don't know how strict she is on these things.
Yeah, we basically want to get that. All of us need to work and make sure that most of the contents are in, right?
Yeah.
The final fix-ups of anything that we need to do, we can do it, but just get it in. This is a forcing function.
I get that.
Okay, I don't have anything else. Then I will cancel this series. Then I will schedule the Friday one either later today or tomorrow, and send it out for the team. It is probably we meet next week, and we have to and the following week. I'm not sure. That's at least meet this week, this Friday.
This Friday, yeah. I think that'll be better, Sammy, because that'll give us more time to work through everything.
Yeah, the final things I can also kind of share the presentation to this team and make sure that any tune-up need to be done, we can do it. Okay, team. Then we will see you this Friday. Thank you, Mohan, and thank you, Rob.
Yeah, thank you.
Yeah, thank you. Thank you, Sammy.